Why hello everybody and welcome back to the Arduino Zumo Shield robot build once again on my channel. Today we are going to be going through the deeper analysis of the void loop. So we're going to start at the very top and we're going to comment it continuous loop. It's going to keep doing this whatever we write in here. We could write whatever, we could write stand still, and it would only stand still. So let's go down into the loop. We're going to start at the very top. So it's going to go unsigned integer senses 6. So what that is saying there pretty much is unsigned I'm not too sure what that means, but it's pretty much saying there is a number of senses and that is 6. Senses was defined before, so that's pretty much saying number of senses, there's 6 senses. Alright, so then we're going to define another number variable because integer is always a number, so position. So this is obviously a global variable or a variable built in. So the position is a number and it is equal to the reflectance senses, which is what we defined before. Remember, as a global variable. So as what we defined before as a global variable. So I'm just going to write this in and then I'll explain it. Senses. So what this is saying is the position as a number is equal to the reflectance senses. So that's defined in the library, the senses library. And what we want it to do is read the lines from the senses, which is again defined up and top. Both of these ones are defined. So that's just making sure that its position is a combination of these things here. I hope that made sense. It gets a little bit tricky here just because it's actually moving, but I'll try and explain it to the best of my ability. So the variable error as a number is equal to the position take 2500. So I think 2500. So our error is how far we are away from the center of the line, which corresponds to position 2500. Alright, so position 2500 is obviously the middle of the senses. That's where the middle of the line is. The middle two senses need to be at position 2500 to see the middle of the line. So the error is going to be whatever we are over the line, take 2500, because that's how much we have to adjust to, if that makes sense. Our error is us adjusting, so that's going to tell us how much we have to adjust by it. So that's what we're defining there. Now we have to we don't have to define anything, sorry. We need to do the math to work out how fast we have to turn either way. So that's speed difference, and that is equal to our adjustment angle divided by 4 plus 6. So there's a bit of Arduino math here. I'm guessing this is predetermined. They probably worked this out somehow. I'm not sure how they worked it out, but you need to have this math exact, otherwise it won't work. I'm guessing. Don't quote me on that. I'm not too sure, but just do it the same. So what this is doing is defining a number variable, because integer, a number variable named speed difference, and that is equal to our adjustment angle or adjustment position divided by 4 plus 6 times our error, so our adjustment position, take last error, which is 0 the first time through because that is our global variable. And then we need to overwrite the global variable and say, hey, look, the last error is no longer the error 0, it is actually now a variable that we defined before, which is error. So it needs to override it, and that's just making sure that the last error is always valid, because when it goes through, it's going to go through in a logical order, and last error will be after we calculate the error in the position. So that's good. We're updating it, making sure it's valid. Now we have to set up somewhere for our speed, two different speed levels to go. So we only have 2 different speed levels. You can make more speed levels, but there's a lot more math to be involved. So we're just going to go with the 2 that they've given us. So max speed 1 and speed 1 and speed 2 is equal to max speed, and then for speed 2, we're on speed 2 already. Max speed take speed difference. And down below, we're going to determine which speed we actually use. So the speed difference is going to tell us how fast we need to speed up or slow down. So that's what we're going to do down here in the math, which is what we're going to do right now, which is our if statements. So if M1 speed is less than 0, do something. So I'm going to go 2 down. If, I'm going to just do all the if statements first. If our second speed is less than 0, do something. If our first speed is greater than our max speed, we can go max speed, so do something. And then if our second speed is greater than our max speed, you can do something again. So for the first one, which reads, if our first speed is less than 0, M1 speed equals 0, which is going to make it stop. It's going to stop in its tracks. Don't actually need them there, my bad. I don't know what I was doing. Do need to tab that in though. Tab. Cool. If M2 speed is less than whatever, we want our second speed to be 0, because obviously it should not be moving, so we don't want it to move. Make these neat, sorry. Okay, so if our first speed math calculation is greater than max speed, then obviously we can go max speed. So M1 speed is now equal to max speed. And then if our second speed is then, again, in the math greater than our first speed, we can go max speed, because obviously we don't need to slow down or adjust in any way. So how about we just go full pole until we actually have to adjust, and it does the math pretty quickly to be able to adjust that. And then that's the math. We'll go through that in a minute. And then we have to output it to the hardware. So we're going to go motors. So that's telling the motors. Then we're going to give it a command to set the speed. So set the speeds to M1 speed and then M2 speed. So that is done. So let's go through it. We'll go through it in English and comment on it so you guys know what you're doing. So up the top, it's a continuous loop. Remember that. So here, it's going to tell the hardware how many sensors it has. There's 6 sensors. It's then going to define the position as a number according to the sensors. So that's pretty much reading. The position as a number is equal to where the sensors read the blackness of the line according to the sensors that are defined up the top. So that's just a little bit of a it reads off the 2 different sensors, the reflectance of the shield at the front, and the actual infrared sensors and where they're reading on the ground. This one is an error as a number is our position on the our position over the line, take 2500, which is the middle of the 2 infrared sensors. So what that's saying is the error, so how much we have to adjust to, is our position on the line, take what the middle 2 sensors see, because that's going to then tell the middle 2 sensors where it needs to adjust to be able to see the middle of the line, not what they think they're seeing the middle of the line is. I hope that makes sense. That's the best I can explain it. Okay, so our speed difference as a number is equal to our adjustment, so that's what we did just before, the error, our adjustment, I can't spell, our adjustment divided by some math. That's what the math is. Divided by some math. So that's what the math is after that. I'm not going to go through that. It's pretty self-explanatory. And then overwrite last error to make it valid. So we're going to make sure it's valid. Just remember that's got to be valid. Alright. And then we've got to go M1 speed as a number is the max speed plus our speed adjustment. So if that is greater than our max speed, then it's only going to go max speed. It's not actually going to go faster than our max speed, because that's going to burn out our motors. That's what we said down here. And then speed to take our adjustment speed. And that's just going to make sure we don't overshoot anything. And then this here is give logic for the hardware to adjust speed. So that's pretty much going to tell this one, the if statement says if it's less than 0, stop. If the second speed is less than 0, then stop that speed. This one says if the first speed is greater than max speed, then only set the first speed to max speed so we don't burn out the motors, and that's the same for the second one. And then this one here is output to hardware motors. Now that is a little bit confusing to understand, but we did have to go through it just so we're not actually technically, well, we are plagiarizing, but it is open source, so we're not technically plagiarizing, but it's good to understand what we're actually working with and what we're kind of copying here. So we went through it. I hope it does make sense. We went through it in English. We just went through it. I'll go through it really quickly again. It's a continuous loop. We're telling the robot how many sensors it has. We're telling it how to read the lines and how to set itself a position. We're telling it how to get its adjustment error, and then we're going to tell it, according to its adjustment error, how fast it has to adjust, like how fast the wheels have to spin to be able to adjust. We're then going to make sure that the last error variable is valid with the current adjustment error, and then it's going to work out that with the error and the speed, it's going to work out with the speed difference, so how fast it has to adjust each wheel. It's going to work it out with the max speed, and then the if statements is going to make sure that we don't burn out the motors, and if we can't adjust, it's actually just going to stop, and then it's going to output it to the hardware. There you go. That's pretty much it. That's that's done. That's all you're going to know, and now it works. So you can upload it, you can verify it. Oh, we got to save it, so we'll go line follower, tut, save. So verify it. It's going to compile. Oh, I typed that wrong. So let's go over here. We're going to copy. You can go back up to the top where your global variable is. So this is just saying reflectance sensors was not declared in this scope. This scope is what we're working in. So I spelt it wrong, which means that variable doesn't actually exist. So when we verify it now, it should work. That's wrong. So we didn't adjust it again. It was expecting an equals to, was it? I think there's only meant to be one there. Oops, what have I done? Token before that thing. So maybe there is meant to be 2 there. So that one's there. Okay, where's the if statement in the other one? Oh, it's because we didn't have a primary variable, so now we do. Cool. Motors, I did spell that wrong. Motors. Oh, wasn't there. What? Did I spell it right up here? Did we define it? We didn't even define it, so we've got to define it again. So this is the troubleshooting stage, right, guys? So we are compiling it, we are going through it and having looked at it all works. M1 speed, so we had a capital, so it is case sensitive, remember that, M1 speed. Compiling, alright, cool, no more errors. It's compiling, it's going through, making sure everything is correct. That's the really good thing about the Arduino software, it does all that for you. Cool, it's all working, so now that we compiled it, we can upload it to our robot. It should make a little buzzer noise when it's done. And it should... Cool! It made the buzzer noise that I wanted to make. So that's this here. That's what you just heard. I don't know if you heard it or not. But that's that one. It's whatever you've written. So you should be able to hear it. And that means you're good to go. You can lay it down on your track and you can test it out. Alright? So, we're going to do that in the next episode, actually. I was going to modify it in the next episode, but... no, I'm not going to. I'm going to build the track, and we're going to test it out on the track. So the next episode is the testing phase. Congratulations, you now understand the line follower. You now understand the line follower code, and you know how it all works. And now we get to test our robot with the code you coded yourself using the example from Arduino. So that's really cool. Thank you very much for watching, and I will see you in the next one for a very exciting reveal and testing of our robot.